Theoretically speaking, by now, we know what is an array and why we need an array. Whenever you have a list of data and you would like to pass over this data more than once, then you need to save the data in the memory, and the only way to do that is by an array. Let's talk technically more about arrays and discuss arrays in details. First, how to declare and create an array. You know that an array is an object. So you declare and create an array in almost the same way that you declare and create objects of classes. But there is only a slight difference in the syntax, is that you include the size of the elements you want to allocate in the array. This is the syntax. You write the base type, either a primitive, integer, double, long, or a class type like a string or a user-defined class, followed by empty square brackets to tell the compiler that this is an array, followed by the name of the array, which is a reference, then the command to create the elements of the array equal a new, and then you repeat the base type here, but between square brackets you determine the length or the size of the array that you want to allocate in the memory. Some examples on how to declare and create an array. Here we are creating an array of characters. The name of the array is symbol, and we are allocating 80 characters. The next example, we are defining an array of double. The name of the array is reading, and we are allocating 100 doubles for this array. In the last example, we are declaring an array of a user-defined class. Species is the user-defined class. In this declaration, we are declaring an array of a species, and we are allocating 80 references to this class. In this declaration, you have to know that we are not creating 80 objects of this class. We are just creating the references. Therefore, if you want to create objects for these references, then you have to go over the elements of the array one by one and create an object for each of them. We want to define some arrays with some data types, and we want to see how Java creates these arrays and what are the initial values that are stored inside these arrays as default values. First, we will create an array for 5 double values. To do this, you specify the data type, which is double, then you put empty square brackets to tell Java that this is an array, and you give the array name, and we will call it array1. You put equal, and you put the command to Java to tell Java to create an array, and you write the data type, and you specify the data type between square brackets, the size of the array. Let us create an array of integers. So create an array for 5 integer values. Similar to double, we will write integer int, empty square brackets. The name of the array, I'm going to call it array2, equal a new int, between brackets we write 5, which is the number of integers for this array. Let us create an array for 5 characters. Then we write char, empty brackets, we will call it array3, equal a new char, between square brackets we specify 5. Let us create an array for 5 string values. Then we write string, empty square brackets, we write array4, we write equal, and we write the command to create the array new, and then a string, between square brackets we specify the size of how many strings we want to create. Finally, we would like to create an array of an object. We already have a class that's called flower that we have defined before, and we are going to create an array of objects of a flower. So create an array for 5 objects of type flower. The syntax, you write a flower, which is the class type, square brackets, and you give it a name. We will call it array 5, put equal, new, and then the name of the class, which is a flower, between brackets, we put the size of the references of this object. Now, when we create an array of double, the system will put default values, and we want to see these default values. Similarly for integer, char, and string. However, for the last array, it does not create objects of type flower and save them into the array. It will just create references for objects of type flower. Let us run the program through the canvas. So we need to see each array, how it is initialized by the system. We will make a space for the canvas. Now let's go to the first step. Now the array, the first array, array 1, has been created. We will drag it into the canvas and see now the initial values for this array. It has been initialized to all 0 double values. Now when we go to the next array as integer, we will drag it also and see it is also initialized all to zeros but integers. When we go to the array of characters, when we drag it and see what are the contents inside, all initialized by the ASCII code 0. When we now initialize array of strings, it will create references to these strings. See these small square dots? That means that these are references to empty strings. So it does not create strings. However, it creates references to strings. If you want to save strings inside these array elements, then you have to go over these elements one by one and save strings inside it. Finally, for the array of a class flower, we will drag the array, which is array number 5. And again, it is also creating 5 references to objects of type flower. Again, these small square dots, they are referencing to an empty reference. We will call it later, or the Java system call it null value. Here we are not creating any object of type flower. We are just allocating a space for their references. If I want to create 5 objects of a class type, then we have to go over each element, create an object from that element. As an example, for a quick example, I will stop the canvas. Now, if I want to create one object, one of the flower objects, and save it into the first element of the array. So we say, what's the name of the array? It is array 5. Between a bracket, we say 0. We close the bracket. We say equal. And now we will create an object of type flower. And we will say new flower. And we will use the default constructor to create this object. Now we have created an object, and it is referenced by array 0. Run it. So now we will see this value into the canvas. Let us just drag. Let us run it. Let us drag now the array and see, notice that the first element of the array is pointing to an object, but the other references are pointing to empty references. We've mentioned before that arrays were objects. Therefore, their names were just references or pointers to these arrays. Since the array name is just a pointer to an array as an object, that means we can create a new array as a new object and make this name points to the new array. Let us experiment on this and show you how this happens. Let us make a new array of integer of size 5, call it A, integer. As an array A equal to new integer, let's say 5. So now we are creating an array of size 5, and A is a reference. That means it is pointing to this array. Now let us put 2 values in the beginning of the array. Let's say in the first element we will put 100, and in the second element we will put 200. Before we change the pointer to a new array, let us visualize graphically how A is pointing to the array. We will run the canvas. And now we'll let the canvas go to line 20. Let's go to the next step. Now the array is created. Let us see it visually, graphically, how it looks like. See now, the array as an object is inside the box. And A, which is the name of the array, is just a reference. It is a pointer. See, it is pointing to the object. Now, when you execute line 22, 100 is saved into location 0, and 200 is saved in location 1. Now, what we will do, we will create a new array, and we will make A points to that new array. So let us stop the canvas, and let us go here. And we will say simply A. Now, how to create a new array? You say new integer. Let us say we want to create a new array of size 3. Now, I want A in the beginning was pointing to an array of size 5. Now, when you say A equal to a new integer of 3, then a new array will be created with 3 elements, and A will point to this new array, and the old array that had 5 elements will be deleted by the Java system. Let us run the canvas again. And let it go to line number 22. And now see the array is created. We will put the values inside it. And now the first element is 100, the second one is 200. Now when we execute this statement, a new array will be created. And see, a new array has been created, and now A is pointing to this array. And it is initialized by the default values or to zeros, because the previous one is deleted from the system, and Java system just simply take it out from the memory. Now let us make another experiment. We will stop the canvas, and now after declaring the array A, we are going to declare a reference only to an array. So we will say integer, we will call it B. We are not going to create a new array. However, we are going to make it equal to A. Now you might think that we have 2 objects of 5 elements. One is pointed by A, another one is pointed by B. However, in the first statement, you are creating an array of size 5 integers, and A is pointing to this array. Now, when you say that B is an array is equal to A, it doesn't mean we are copying the array A into B and having 2 different arrays. One is pointed by A as the original array, and the copy is pointed by B. However, it means that B as a reference is equal to the reference of A. So if A is pointing to an array, then B is pointing to the same array. To prove that A and B are pointing to the same array, here after putting some values, what we will do, I will put in the first element of A 100, and I will put in the second element of B, and I will put 200. Let us remove this new array. We don't need it now. Let us run the program again with the canvas and see how it works. Run the canvas step by step. Let us go until this statement. So we will go up to line 23. Now we have created an array A. Let us drag it. So this is array A. Now I want to put 100 into the first element of the array by using A. So when we execute the statement, so we are saving 100 into the first element. Now we said that B was pointing to the same array as A. So now if we want to change the first element into 200, then we have to see this change is reflected in the array. So let us run it and see now the second element has been changed, but it was not changed from A, it was changed by the reference B. Now if you try to drag and see graphically the values of B, you will notice that both will be equal to the same array, but they are not different copies. Visually, they look like different, but in fact, they are the same. A and B are pointing to the same array.